The graduate presenter is a water researcher and was the recipient of the Joan Rose Water Fellowship in 2015. Her mentor, Nathaniel Ostrom, is a professor in the Department of Integrative Biology and focuses on environmental science and policy. I want to extend my congratulations to the students and also my sincere thanks to these mentors and all faculty research mentors on campus.
As a professor, one of my greatest fears is that sooner or later my graduate students are going to figure out they're smarter than I am. And I can absolutely assure you, I might be a little smarter than Kateri. I'm not too sure, but close. But I can absolutely assure you that I was nowhere near as accomplished at her level of her career as she is now. She joined us from St. Olaf University with a 3-year full-ride fellowship from the National Science Foundation. She got an additional 1-year fellowship from the Environmental Science and Policy Program and the College of Natural Sciences. She wrote another grant to the National Science Foundation, the East Asia Pacific Sciences Institute, that let her travel to Australia for 6 months and study at Southern Cross University and take up surfing, I should add. And she's also a fellow with the Graduate School's Future Academic Scholars in Teaching program, where they were so impressed with her that they asked her to come back. And of course, she's also a recipient of the first the Rose Water Sciences Fellowship, which Dr. Joan Rose here at MSU established after she received the Stockholm Water Prize. So it's my pleasure to introduce to you Dr. Kateri Salk.
Well, thank you for the introduction, and thank you for having me here today. So I'll start by telling you how I came to be doing graduate research here at MSU. So I grew up in a very small town in central Minnesota, the land of 10,000 lakes, where I always grew up around the water and sort of grew up with this fascination for lake systems. I then took that fascination to St. Olaf College down in southern Minnesota for my undergraduate degree, where I really embarked on this study of water for my own research. So I took this fascination that I grew up with water and also combined that with the biology and the chemistry and the physical movement of water in lake systems. I then decided I wanted some more, so I started looking into PhD programs to study water, and I came up with coming to Michigan State. So I enthusiastically became a Spartan, and in part this decision was due to the ability to work with Nathaniel Ostrom, who so kindly introduced me today. And Nathaniel was a really great person to work with because he's an expert in this use of what we call stable isotope analysis, which is this tool that we can take these biological and chemical and physical movements of water and transformations, and we can sort of parse them out with this tool. So Nathaniel and I began working together with me as a PhD student. One of the topics that we've been really fascinated with in our lab is harmful algal blooms in Lake Erie. So I had this really wonderful picture of this harmful algal bloom that's occurring in Lake Erie in 2015. So just to orient yourselves, since it's a little small, this is the western basin of Lake Erie, and here's the central basin. And you see all of the green color in here is a harmful algal bloom that's occurring. And one of the questions that we have in Lake Erie is that the offshore regions, these deep water regions, are dominated by microcystis, the species of cyanobacteria, which we heard about from the previous group, whereas the inshore is dominated by this other species of cyanobacterium called Planktothrix. And so one of our questions is, why is microcystis occurring in the offshore, and why is Planktothrix occurring in the nearshore? And we have a hunch that it has something to do with nitrogen. So that same chemical compound that we can use to fertilize our crops can also have the capacity to fertilize these harmful algal blooms in Lake Erie. And this may be influencing these harmful algal blooms differently in the nearshore versus the offshore. So we have this question. So then I'll sort of talk you through my research process for once we have this question and we want to investigate it. So we collect samples. So this can be anything from collecting water and sediment off the side of a boat with an outboard motor, all the way up to living on a ship for a week and eating and sleeping on the ship, but also using some more heavy machinery to take samples from deeper regions of the Great Lakes, hence this hard hat there. So I'll talk you through more of the research process. So first we collect samples, then we're able to bring those samples back to the lab and analyze them. So this is one of the instruments that we have in our lab where we're able to analyze the stable isotopic composition of nitrogen in the water. We're then able to generate data based on that. So here's just a single graph from one of the projects that we're working on. And what we found is that the availability of nitrogen, when we have high availability, that's not associated with the times where we see high blooms of Planktothrix. So parsing out what the reason is for that has been really fascinating. So then we're able to synthesize our results once we have enough of those data generated. And I've been lucky enough after that synthesis happens to communicate these results with scientists, so at venues like the Association for the Sciences of Limnology and Oceanography meeting, where I presented in March some of the research we've been doing in Lake Erie to the greater community of harmful algal blooms researchers around the world. But then there are also other venues where not only scientists but also managers and the public can get together, like the Great Lakes Harmful Algal Blooms Collaboratory. So I'm part of a group there where we talk about nitrogen and our current understanding of nitrogen and maybe future directions for nitrogen research. And we also pair with managers who are enacting this policy on the ground to try to manage these harmful algal blooms as that contributes to nitrogen. And we also communicate with the public, so people that care about the health of the Great Lakes and mitigating harmful algal blooms and what our understanding can sort of do for them. So some research outcomes from this research. So phosphorus is normally the nutrient we think about when we're thinking about controlling harmful algal blooms in Lake Erie. But we've noted that nitrogen, in addition to phosphorus, has an influence on the formation and the persistence of these harmful algal blooms. And we've really noted, so based on that microcystis versus Planktothrix problem that we have, that nitrogen is impacting these harmful algal blooms differently in the nearshore versus the offshore. So if we're looking to manage these harmful algal blooms, we might need to think a little differently in the offshore versus the nearshore. And of course, if we're thinking about how climate change might impact all of this, we're expecting to see longer periods of drought, but also increased intensity when we do get those rain events. So we've noted that these impacts on these harmful algal blooms could be more dramatic as climate change progresses. And one thing that has been really important for me is thinking about how communicating with both managers and the public is key. So taking the knowledge we have as scientists and bringing it to the people who are perhaps managing those harmful algal blooms on the ground, and also the public, so the people that care about the health of the Great Lakes and how they can help and how our information can be transferred to them is very important. So I'd like to end with talking about some of the very unique opportunities that MSU has provided to me throughout this process. So by virtue of being the Great Lakes state, of course, I've been able to cultivate a really nice network of not only Great Lakes scientists, but also managers and stakeholders from the public who really care about the health of the Great Lakes. At MSU, there have been some wonderful places, such as the Water Science Network, that have provided this nice community with wonderful expertise on studying water, but have also provided some excellent small research grants that have really helped get these projects off the ground and moving. So not only research, but I've also taken this opportunity to embark on some professional development in teaching and learning. So through the Future Academic Scholars in Teaching program and the Inside Teaching MSU program through the graduate school, I've been able to sort of keep up on the latest instructional techniques in science classrooms and also do some research on my own in classrooms at MSU. So this has really contributed to some of the wonderful innovations that are occurring at MSU in our science, technology, engineering, and math classrooms, but has also provided me with an opportunity for some leadership development as I look toward a career that will hopefully involve teaching. So with that, I'd like to thank everyone for their attention and happy to take any questions.
I've got two questions. The first one, is there anything good about algae blooms? Is there that you're aware of?
So algae blooms can actually sequester carbon dioxide out of the atmosphere. So they use carbon dioxide to generate energy through photosynthesis. So that can be a possibility, but that also is contingent on the fact that they need to bury that carbon perhaps in the sediments to sort of stabilize it permanently rather than having it go back into the atmosphere.
Well, the second question goes, you were the recipient of an awful lot of grants and awards and whatnot. Would I guess the possible cuts to the Environmental Protection Agency affect people like you in terms of research that you're doing, in terms of grants?
So I've certainly been the recipient of a lot of wonderful federal funding. I haven't received any specific funding from the EPA, but grants like that, like the EPA STAR Fellowship, which provides graduate students with research support, that is certainly sort of on the chopping block and is something that could impact the ability for graduate researchers to conduct their work.
Did you want to add to that? There's a
Great Lakes Restoration Funds.
No, that was a great question. I did want to comment that phytoplankton blooms are actually beneficial because it's a food supply for the whole food chain. But what's happening in the Great Lakes is they're being replaced by these harmful algal blooms. And that is a consequence of the way the Great Lakes have shifted and how we're managing them. But in terms of funding, yeah, we're worried. Sea Grant is on the chopping block. And that's been a major program that supported me over the years. And the Great Lakes Restoration Initiative as well, which is a huge program, $25 million a year. So.
In your research, are you identifying any new best practices, particularly for agriculture? You looked at drainage tile, those kinds of issues, cover crops, and how not all conservation programs are created equal for different soil types.
Certainly. So that's something that in that Harmful Algal Blooms collaboratory that I've been working with, we've been talking about once the nitrogen gets into the lake, what happens with it, and sort of thinking about some of these maybe best practices for agriculture that might be helping with that. So certainly, if we're expecting to see more of those large rain events that are causing more runoff, finding ways to decrease that runoff is certainly ideal. But that's a little bit more upstream than what I'm currently working on. Thank you.
Other questions? So 5-10 years from now, what's your dream?
So my goal is to get an academic position as a professor where I can not only do more of this water research, but also do more teaching and mentoring. So
Perfect.
MSU's been a great place to prepare for that.
Thank you very much. Thank you both of
Thank you.
One of the things in response to your question, embedded in all of these cuts is like the STAR Fellows. The pattern, even in the prior administration, was to reduce graduate opportunities through the Department of Education. And so there's just embedded in lots of small places the support for people who are working as the next generation of scholars, apart from all the graduate students who are supported on research grants in general. And so it's hard to identify all of those as we try to go from the skinny budget to the actual budget, and then what decisions will be made in the agencies and how they will prioritize preserving STAR Fellows or the kinds of grants that she's received from other agencies versus bureaucracy or other regulations or it's all sort of uncertain how that will all sort out.